Hello, in this video we're going to write a tool that my students are writing in class, and that is a base 10 to base 2 conversion tool. So we're going to go through how we do this mathematically because that's what's going to allow us to code it. And then in the following video we're going to generalize this to do a base 10 to base n, meaning you can pick any base to convert because it's the same process. Let's start off by just converting 53, which is a base 10 number, into base 2. And the way that I teach students to do this quickly is to start off by writing all the powers of 2 until you pass the value, until you get a number greater than 53 in this case. So 1, 2, 4, 8, 16, 32, 64. So I've hit 64, and if that bit is on, we're going to contribute 64 as a value. So I'm going to get rid of it because that's more than 53. And I'm going to start off by turning on 32. So we're going to turn that on. And so then what I have to do is I have 53 and I'm going to take 32 away because that's going to contribute 32 to that. So I'm going to say 53 minus 32, and that's equal to 21. Let's put an arrow here so we can see it a little clearer. So now I have 21 left that I have to account for. So we're going to turn on the 16-bit. And so what I do now is I say 21 minus 16, and that's going to give me 5. Now, I only have 5 left, so I'm not going to turn on the 8-bit, but I am going to turn on the 4-bit. And so what that leaves us with is 5 minus 4, which is equal to 1. I have 1 left, so I'm not going to turn on the 2-bit, but I am going to turn on the 1-bit. And so that's going to give me 1 minus 1, which is 0, which makes me feel good because now I've basically accounted for all of the value. Now, 2 little things to be aware of is that if you happen to hit 0 earlier on, you just fill it in with zeros the rest of the way. And also, I feel good about this because I know that because this is an odd number, the 1's digit has to be on. All right, but how would I do this mathematically? And what we do is we take this. Oh, before we go on, let me translate this. So now if I want to write this as binary, it will be 1, 1, 0, 1, 0, 1. And that is 53 in binary. It's going to be 32 plus 16 plus 4 plus 1. But if I want to do this using a mathematical process, what I do is I take 53 and I divide it by 2. And then I get that value. So the result of 53 divided by 2 is going to be 26, remainder 1. And both of these are important. The 26 is important and the remainder 1 is important. So what I do now is I come down here and I take the 26 and I divide it by 2. And that's going to give me 13 remainder 1. Sorry, that's going to give me 13 remainder 0, pardon me. And now I take the 13 and I divide by 2, and I keep doing this until I get to 0. 13 divided by 2 is going to be 6 remainder 1. Let's line all these up. So then 6 divided by 2 is going to be 3 remainder 0. 3 divided by 2 is going to be 1 remainder 1. And then 1 divided by 2 is going to be 0 remainder 1. And I'm done. So now what I do is I take this and I say 53 in base 10 is binary 1, 1, 0, 1, 0, 1, which is reading from the bottom up. We always write it down. This is the leftmost digit, and that's the rightmost digit. And so what the process here is that we need to continually integer divide by 2 and then use the remainder until we get 0. So let's write this. So I'm going to say def base 10 to base 2, and we're going to take a value n. And I'm going to say result is equal to an empty string because I'm going to use string construction to build this. And I'm going to do while n is greater than 0. Well, what am I going to do? Well, I'm going to say result is equal to, and now this is parts where you have to do a little thinking here. The last digit that I calculate is the leftmost digit. So result is going to be equal to what? Result is going to be equal to n mod 2, right? Because we want to get the remainder out. and then plus result. And now, some of you might have caught this issue right here. Remember, result is a string, but if I take n mod 2, that's an integer. So we're going to get incompatible types here. So I'm going to take this and I'm going to cast this to an integer. And so now I've pulled out the value that I want to add to result, and now I integer divide n by 2. So n is equal to n integer divided by 2. And then I return, when this loop is done, I return the result. And so this is simulating that process. And now we can run a test case. So if I say, let's print base10 to base2, and we're going to pass into this, let's pass in 53 and see if we've done this correctly. Type in Python 3 base10 to base2.py. Oh, and I get an error. Where's my error here? How many of you saw me do this? I totally casted this wrong. I casted it to an int, and I actually want to cast it to a string. I stand corrected. So let's save this now, and then we're going to give this a run. And there we go. 53 is, what did we say, 11010. And if you come over here, I have a couple other examples here. If we take a look at 62, 62 should be 111110. So let's take this and we'll copy it again. We'll put in 62. 62. And another example I have down here you can find is 45, which is 10110. So let's paste this again. And we'll say 45, and we're going to give this a save. And now we'll give it a run. And there we go. We see that those three values work well. Again, I talked to my class a lot about testing and picking good test cases. So I would encourage you to test the value 0 in this to make sure it works properly. And picking a variety of situations. So maybe a situation where all of the values are on would be useful as well. If you have any questions, please don't hesitate to reach out. Have a wonderful day.